All right, good morning, ladies and gentlemen. This is Mrs. Quinn's Geometry, section 5.4. And today we're going to work with proofs that are a little bit longer, and we're going to focus on the transitivity theorem. So keep the transitivity theorem either on your theorem sheet right in front of you or just in the back of your mind. We're going to use that theorem a lot today. And we're going to have more than just one step to these proofs. These are going to be multi-step proofs. So for this first proof, I went ahead and wrote down my givens already. I am given that triangle ABC is congruent to triangle DEF. What I want to prove is that angle HCG is congruent to angle DFE. So I'm going to start with the fact that I know that if my shapes are congruent, corresponding parts of congruent figures are congruent. That's actually the name of the theorem, right? So I'm going to start with the fact that I know that this angle and this angle are congruent. So that'll be my first step. Step one. Angle ACB must be congruent to angle DFE because of the congruent, corresponding parts of congruent figures are congruent theorem. That's CPCF theorem. And then after that, why would I know that these two angles are congruent? If I look at them, what kind of angles are they? Hopefully you agree that they are vertical angles, right? So now I can say, hey, angle ACB is congruent to angle HCG because of the vertical angle theorem, right? All right, so now that I've done that, notice that I have ACB equaling both of these. What I want to be able to say is HCG is congruent to DFE. And how can I do that? My final step. What theorem tells me that if it's equal to both, they're equal to each other? That's right, this is transitivity theorem. When you have three things, and you know A is congruent to B, B is congruent to C, then A must be congruent to C. So I'm going to be able to say angle DFE is congruent to angle HCG due to the transitivity theorem. All right, let's try another one. If rectangle ABCD is congruent to XYZW, and I know that D is the midpoint here, I want to be able to show that DK is congruent to XW. Let's fill in the congruency marks for what we already know. If D is my midpoint, does everyone agree that this segment must be equal to this segment? Absolutely. And do I know anything else? I think that's all I know from my given. So I'm going to go ahead and begin my proof. And I'm going to start with what I'm given. ABCD is congruent to XYZW given. And D is the midpoint of AK. This is also given. Maybe I'll just write my given a little bit bigger. Both are given. And now, remember these marks we made? We need to include mention of those in our proof. If D is the midpoint, then I know that AD must be congruent to DK. So why don't I go ahead and write that next? AD is congruent to DK. And now I can say, oh, definition of midpoint, true? I actually know that their lengths are congruent. How could I actually say their values were congruent? If I know their lengths are congruent, I know that they are congruent because of the segment congruence theorem. Agreed? So the next thing I could say is that AD is congruent to XW because they're corresponding parts of congruent figures. So now I'm going to say AD is congruent to XW, corresponding parts of congruent figures are congruent theorem. And now look what I can do. I totally have transitivity at this point, don't I? Now I can say AD is congruent to XW because of the transitivity theorem. Now so far we've only written our segments as the length. Notice that there's no line over the top. If I want to go ahead and be able to write it in this form right here, oh, and I wrote the wrong thing over here. Sorry, that's not AD, is it? If AD equals both, then I know DK equals XW over here. Now, notice that these are talking about lengths. If I want to talk about the segment, what theorem do I have to use? I just said it a second ago. That's right, that's the segment congruence theorem. Now, notice that we had quite a few more steps here, but this first one was given, and this first one we could see from our picture, and and these ones were the ones we had to actually come up with. So you have 3 steps where you have to start to be comfortable to recognize these things right here. But you can do it. Oh no, we're not ready for tomorrow. We have one more thing for you, and then I'm going to have you try a proof. This is a transversal. Let's call this L and M like I usually do, and it's cut by transversal T. And notice that measure of angle 2 and measure of angle 3 are right here. Are they corresponding? No. Are they vertical? No. What kind of angles are 2 and 3? Hopefully you thought linear pair. They're definitely a linear pair of angles, so we know that their sum equals what? Absolutely, 180 degrees. So to find x and then measure of angle 2, I am going to add the measure of angle 2 and the measure of angle 3 and set it equal to 180. Then I can add these pieces, combine like terms. 15x plus 10x gives me 25x. And 5 plus 25 gives me 30. I am almost solved for x. Now I can subtract 30 on both sides and get 150. And how many times will 25 go into 150? Hopefully you'll agree with me, it's 6 times. And so I know x equals 6, solve for that first portion. And for the measure of angle 2, now I simply plug in 6 into this value, and I have the measure of angle 2 is going to equal 15 times 6 plus 5. And that would give me my 150 plus 5, which is 155 degrees. Now notice that measure of angle 2 doesn't look like it's 155 degrees. That often happens, and we have to rely on our algebra, not on what the figure shows us. Now for the second one, if we know the measure of angle 3 and the measure of angle 5, these are going to be equal because 1 and 3 are vertical angles, and 3 and 5 are vertical angles, and 5 and 1 are corresponding angles. Does everybody agree that those angles must be equal? Good. And so we're going to set these measures of these angles equal to each other. And when I do that, I can subtract 12y on both sides, and I get 8y. I can subtract 1 on both sides, and I get 2. And so finally, I get y equals 1/4. And I have a little typo here that says x equals. It should say y equals, and y equals 1/4. Now to find the measure of angle 4, I am going to first need to find the measure of angle 3. Agreed? So I'm going to plug 1/4 back into the measure of angle 3. And would you agree that 12 times 1/4 is 3, plus 3 is 9 degrees? And so if that's the measure of angle 3, then to find the measure of angle 4, I am going to have to subtract 9 degrees from what value? Well, hopefully you would agree that their sum, again, has to equal 180. True? Because they are a linear pair. So I'm going to subtract 9 from 180. I'm going to get 171 degrees. And I have found y and the measure of angle 4. Now for tomorrow, I would like you to actually give a shot at this proof. It doesn't have to be perfect. I just want it fully attempted to the best of your abilities. And we will start with this one tomorrow as well.